You know what's better than 2 videos? 3. That's right. This is our 3rd filling and wrapping summary video.
Do I have to watch these?
Oh yeah. I'm sure all of you are pretty excited about it. All right. It's almost like we planned that exchange, but we didn't, I swear. It's totally spontaneous. A beverage company has decided to change the packaging for a juice drink. The juice used to come in a cylindrical container with a base diameter of 6 inches and a height of 10 inches.
Someone made their name Jack Hall.
I don't know who Jack Hoff is.
Take off the H.
Oh, that's not good. Seventh grade boys, I know it's the same class. Appropriate names, buddy. Appropriate names. No one's impressed by that. It's kind of gross. All right. The new container is going to be a square prism that fits inside the cylinder. So this distance here is 4.24. This is 6 inches. All right. Actually, this is also 6 divided by the square root of 2 for those math geniuses out there, and a height of 10. All right. What is the volume of the original cylinder? So, cylinder's volume is pi r squared, because that's the area of the base, times the height. So the volume is going to be equal to 3.14 times 3, because that's the radius, squared, times 10. So we have 9, because 3 squared is 9, times 10 is 90. Look, no calculator, right? So we have 3.14 times 90. And now I am going to use my calculator. So we have 90 times pi 3.14. Speaking of, we are totally doing Pi Day stuff. So if you want to start memorizing digits of pi, let's go. All right. So the volume is equal to 282.6, and this is inches, cubic inches. How much less juice can the Prism container hold? Okay, so I need to find the volume of the Prism. So that's 4.24 times 2. Come on, someone should have stopped me when I started making a mistake there. Times 4.24 times 10. That's right, it's all your faults at home that you didn't let me know I was doing this wrong. So the volume, and that's the cylinder, so these are called subscripts. The volume of the rectangular prism is so close to 180, 179.8. All right, so I'm going to call that a negative. I'm going to add 282.6, and I'm starting to rush because I'm running out of time. So the difference, how much less, is 102. Let's call it 103. I'm going to round to the nearest whole cubic inch. All right, so that's part C. Suppose the company wants their cost per cubic inch of the juice to remain the same for both. Let's be realistic. They're probably going to charge the same for both and just give you less. But we'll pretend that we're going to go with that. All right, so we know that 280, I'm going to just round this to 3 for crying out loud. It costs $2.19. And so the ratio, they want to remain the same. I'm just going to round that to 180. So that's 180 over x. And I'm going to use some cross multiplication. So using cross multiplication, we are going to multiply across the equal sign. So we have 283x is equal to 2.19 times 180. So 2.19 times 180. Come on, you need to help me out when I miss. right? And then we're going to divide it. We're doing train tracks.
It's not a good Kahoot day for me.
Sorry. So that means it should cost $1.39. Finally, the company is also considering selling a juice in a cone-shaped container with the same volume as the cylinder. Describe the possible dimensions of the cone. Well, the easiest thing to do, since the cone is divided by 3 versus the cylinder, is just make it 3 times taller. That would be clearly the easiest. It's going to be much harder to deal with increasing the radius because, remember, the volume is scale factor cubed times bigger, and you're already squaring the radius, so that would kind of be a mess. So let's just make it 30 inches tall. All right.